Hello, my name is Brandon, and welcome to the next video in my series on basic statistics. If you are new to the channel, welcome. It is great to have you. If you're a returning viewer, it is great to have you back. If you like the video, please give it a thumbs up, share it with classmates, colleagues, or friends, or anyone else you think might benefit from watching. Now you can also find a link in the description below to all of my playlists. It's basically a table of contents. And of course, please hit subscribe and click the bell notification if you haven't already. So now that we are introduced, let's go ahead and get started. This video is the next in our series on non-parametric methods or non-parametric statistics, and it is about Moody's median test. Now I'm doing this video primarily because I've had several requests for it. Luckily, Moody's median test is actually quite simple and straightforward, and it's easy to understand what's going on. So here's what we're going to do. I'm going to walk you through the background of what the Moody's median test is. We will walk through several examples using different visuals. And finally, we will go into Excel and calculate Moody's median test for a problem that has 4 samples. And of course, in the description, you will find a link where you can download this Excel file and follow along if you like. So let's go ahead and start learning about Moody's median test. First, some background. In the first and second videos in this playlist, we learned about the sign test for a single sample median. Suppose we would like to compare the medians of 2 or more groups. The sign test was only for 1 sample. Moody's median hypothesis test allows us to do just that. So Moody's median is based on the sign test, which we learned about before and is actually quite simple, and the chi-square test, using contingency tables. So if you have seen and used the chi-square test before, you're in really good shape for this video. Now, if you have not, just follow along and you'll pick it up as we go. So Moody's median uses the overall median for all samples combined into one large data set. So if we have 2 samples, we take those 2 samples, we combine the data all together, and then we use the median of that combined data set. And that holds true if we have 3, 4, 5, whatever, how many samples we might have. So think of it as the sign test for more than 1 sample. Now, if the medians are the same, we should expect each sample to have the same proportion of observations below or above the median of the combined samples median. There are a lot of words here in this bullet point, and when we actually see it, it'll be much more concrete. So think of it as a non-parametric version of the one-way ANOVA. Now there is another non-parametric test that we learned about in this playlist called the Kruskal-Wallis test, and it is actually seen as being better than the Moody's median test. It has more statistical power, and it is seen as, quote, better because it considers the ranks of the observations, not just the sign of being above or below the median. So as is the case with all of statistics, there's oftentimes more than one test we could use to answer whatever question we're trying to get at. And in this case, the Kruskal-Wallis test and Moody's median test are basically answering the same question, but in a different way. So here's our general question. Are the independent samples from the same overall population? And a key word there is independent. So each of our samples are independent of each other. They are not paired, they are not blocked or anything like that. We just have independent samples, 2, 3, 4, 5, however many we might have. We could also ask this question a different way. Have the independent samples been selected from different populations that have different medians? So both of these questions are essentially asking the same thing, but in different ways. Are the independent samples from the same overall population, or have these samples been selected from different populations? 2 sides of the same coin. So the general hypothesis is, H sub 0 or null hypothesis states, the samples come from the same population. The alternative hypothesis, H sub A, at least one sample comes from a different population. Again, this is very similar to the parametric one-way ANOVA. So rejecting H sub 0, the null hypothesis, means that there is a difference among the locations of the medians, but we do not know necessarily where. So there are tests that can tell us where the difference in the medians might be, but that's beyond what we're going to do in this video. I might do that a little bit later. So Mood's median test uses the chi-square statistic. It is a comparison between the proportion of observations we observe relative to the overall median versus what we would expect relative to the overall median if the samples came from the same population. So again, that's very wordy. It's much easier to see it visually, and that's what we're going to do coming up. So here are some visual examples of what we're talking about. So here is this overall population, and that overall population has some median. So we take our samples and we compare it to that. So the vertical line is the overall median for the population. We are looking for similar proportions above and below the population median. So here is this first example. We have 4 samples. We can see that for sample 1, 2, 3, and 4, we have approximately or exactly the same proportion of values below that median as above. Look at this second example. So here we can see that sample 1, sample 2, and sample 4 kind of look alike, but sample 3 seems to be a bit over to the right, and it has a higher proportion of observations above the median than the other 3. And here we have sample 1, 2, and 3. So it appears that sample 2 and 3 have a higher proportion of observations below the median, and samples 1 and 4 have a higher proportion of observations above the median. So you kind of see what we're doing here? We're looking to see whether or not these samples have the same proportion of observations above or below the median. So I will continue using the example I've done in this playlist called Mumbai Starbucks. So 60 students from Mumbai, India, who often study at Starbucks, were asked to provide ratings for 4 stores, so 15 students for each store. Each student was asked to review the Church Gate, which we will denote with a letter C, Natterman Point, letter N, Taj Mahal Palace, T, and Horniman Circle, H stores. And yes, these are actual stores in Mumbai, India. The survey covered 5 criteria: cleanliness, service, facilities, drink quality, and food quality, each on a scale of 1 to 5. So the lowest possible score is a 5, if they got a 1 on each of those 5 categories, and a maximum of 25 if they got a 5 on each of those 5 categories. So we would like to test if the medians are the same for the 4 stores. So what we will do is compare the first 2 stores, then we'll look at the first 3 stores, and then we will look at all 4 stores. And the last example of all 4 stores is the one we will go into Excel and actually calculate. So here's how Mood's median works. First, we're going to set up our table. So here are the ratings for the Churchgate and Natterman Point stores. So Churchgate had 15 students that gave it the following ratings: 20, 17, 16, 15, and so on and so forth. Natterman Point had 11, 14, 13, 13, 17, and so on. So those are the 15 observations for the first 2 stores. First, we find the overall median for the combined sample. So we take all of Churchgate's ratings, all of Natterman Point's ratings, kind of put it in the same pool, and then we find the median of that combined data. In this case, it's 16. Then we count the observations that are less than or equal to that overall median of 16. So here's what that looks like. So for Churchgate, the values that are less than or equal to 16 are highlighted in orange, and for Natterman Point, the observations that are less than or equal to 16 are highlighted in blue. So we can see that for Churchgate, we have 1, 2, 3, 4, 5, 6, 7 observations, and for Natterman Point, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're just counting the number of observations that are below or equal to the overall median. Then we put that into a little table here. So we have less than or equal to overall median. Churchgate, it was 7. Natterman Point was 11, for a total of 18 observations that were less than or equal to the overall median. So that means for greater than the overall median, Churchgate had 8 observations, Natterman Point 4, and then that adds up to 12 for greater than the overall median. And then, of course, we have our totals. Now, the total row is also a way for us to check ourselves. Values for Churchgate should add up to 15 because there are 15 observations. Merriman Point should add up to 15 because there are 15 observations. And then totals, we have 30 observations, total. So we look in the lower right of this table and we see 30. So again, this is just our contingency table counting up the number of observations that meet each criteria. So visually, it looks like this. Here's our overall median, and here's where Churchgate falls, and here's where Netterman Point falls. So we can see that Churchgate had 7 observations that were less than or equal to the overall median, and Netterman Point had 11. So visually, it looks like this. Now, what we have to do is use a statistical test, the chi-square test, to see whether or not this difference in proportions is statistically significant. And that's what we're going to do as we go forward. But visually, this is what it looks like. Now, we'll point out that in this example and some other examples, there were several observations that were equal to the overall median, and 5 of those were in Netterman Point. That is why the graphic is sort of lopsided below the overall median. But again, we are interested in the proportion of observations equal to or lower than the overall median or above the overall median. So as long as that criteria applies for both samples, it doesn't really come into effect. So now we're getting into the chi-square portion of our test. So here are observed values that we had before. Now we have to find the expected values. So remember how we do that. In the chi-square, we're comparing an observed contingency table to an expected contingency table. The way we find the expected values is pretty straightforward. So if we go down here to the bottom in Churchgate for less than the median, less than or equal to the median, what we do is we take the column total of 15, multiply that by the row total of 18, and we take that product and divide by the overall count of 30. So 15 times 18 divided by 30 equals 9. And then we do that for all 4 cells of this table. That is how we find our expected values. Now let's do the first 3 stores. So if we look at our data, and it's in the spreadsheet again, well, you can follow along later. So Churchgate had 11, Netterman Point 12, and Taj Mahal Palace had 8 that were less than or equal to the overall median. Now, some of these numbers might have changed because remember, we are introducing the Taj Mahal Palace data, so the overall median probably changed. That's why the counts might be different than the previous slide. But we can see that we have 15, 15, 15, so we know our math is right, and we have 45 overall observations. So our expected values in our table for Churchgate, Netterman Point, and Taj Mahal Palace, it's 10.33 in the top row, and then 4.67 in the bottom row. What we're going to do is use the chi-square test to see whether or not the observed, those 6 values up there, are different than the expected values we have down here in the bottom. So visually, it looks like this. So we can see that Churchgate had 11 equal to or below the overall median, Netterman Point 12, and Taj Mahal Palace 8. And again, in several cases, we had values that were equal to the overall median. That's why it tends to be lopsided over here to the left. Now let's do all 4 stores. So here we have Churchgate with 11, Netterman Point 12, Taj Mahal 8, and Horniman Circle with 0. And again, those are the number of observations that are less than or equal to the overall median of all 4 samples combined. Down below, we have our expected counts of 7.75 across the top row and 7.25 on the bottom row. And all of our columns sum to 15, and our overall is 60, so we know we did our math correctly. And visually, it looks like this. So we can see that the Churchgate, Netterman Point, and Taj Mahal stores tend to be similar, but the Horniman Circle store seems to be way over to the right. It appears to be that all of its observations, all of its store ratings, are above the overall median for the combined sample. So we know there's a difference there. So as we have discussed, the Moods median test is based off the chi-square test, or it uses the chi-square test. So the test statistic is the chi-square, of course, and then our alpha level is whatever we choose, usually 0.05. The degrees of freedom for the chi-square test are the number of rows, -1, times the number of columns, -1. And those are the parameters we need to do the chi-square test. So we reject our null hypothesis if our p-value is less than or equal to our alpha. So we've done this before in statistics countless times. So if our alpha is 0.05, we do the chi-square test, and that comes out to be less than or equal to 0.05, then we would reject our null hypothesis. We could also use the critical value approach. So if our chi-square value that we calculate is greater than or equal to the chi-square critical value for the given alpha and degrees of freedom, again, we would reject the null hypothesis. So in statistics, the p-value approach and the critical value approach are two sides of the same coin. The p-value is the area in the distribution curve. The critical value is a location in the distribution curve that determines the boundary. So they are essentially the same thing. So now that we have the background and some examples of the Moods median test, let's go ahead and go into Excel and calculate Moods median test for the 4-store example we had there at the end. And again, you can pause the video, find the link in the description, download the file, and follow along during the Excel portion. So let's go ahead and go into Excel and calculate it. So here we are in Excel. Let's go ahead and calculate the Moods median test for the 4-store examples. So first, a layout of the sheet. In columns A through D, we have the 4 stores and their ratings for each of the 15 students. In columns F and G, we're going to find the overall median that we will need. And in the right half of the sheet, we have our tables. So on the top, we have our observed frequencies, which will come from columns A through D. And then we'll calculate the expected frequencies using the simple formula we talked about in the presentation part of the video. And then we have our p-value, chi-square critical, and chi-square observed, which is where we will actually get our result. And then we can determine whether or not we're going to reject or fail to reject the null hypothesis. Okay, first thing we need is the overall median. So we're going to use median equals median. Then I'm going to select the 4 columns as a whole. Now I select the 4 columns this way because it makes our spreadsheet more flexible. So let's say we went out and had more students rate the stores, of course, independently of everybody else, and then we added data down the columns. Well, doing it this way makes our spreadsheet more flexible because we're treating a column as a variable. As long as we keep columns A through D, just the store ratings for each store, we can do it this way, and our model will update as we add more data. So let's go ahead and close. Then we have an overall median of 17. So of the 60 observations we have over here on the left, the overall median is 17. Now we need to find our observed frequencies that are less than or equal to that overall median. Now we'll use the COUNTIF function. So equals COUNTIF, and then the range for Churchgate is just column A, comma, and then the criteria is less than or equal to. So I'm going to open a quote and put in less than or equal to, close the quote, and then I'm going to add to that, so an ampersand, G1. Now I'm going to hit F4 on my keyboard to lock that in using an absolute reference, close that, enter, and I get 11. So Churchgate has 11 observations that are equal to or less than the overall median of 17. Now the way I've done my formula, I can go ahead and just drag across for the other 4 stores, and that will fill those in. Because I locked in G1, but I allowed the columns to change. So if I go into Narrowman Point, we can see that it's BB, CC, and DD as far as the columns go. Now for the greater than the median, there are several ways I could do this. So if I wanted to do this the absolute correct way, we would use COUNTIF again. So I'll go ahead and do that. So COUNTIF, our range again is going to be column A for the start of Churchgate here, comma, open our quote, greater than, close it, and for the ampersand, G1, lock it in with F4, enter. There we go. Now I can go ahead and calculate this across. Now the easy way I could have done that is knowing that this adds up to 15. I could have taken just 15 minus the value above it. But this way we make sure that we got all of our observations correct based on the actual data. So we can see we have 15, 15, 15, 15 as the totals. We know that's correct. Then we have 60 as the overall total. You'll notice here that we have 31 observations in total that are less than or equal to the median. Then we have 29 that are greater than the median. And again, this should say less than or equal to. We want it to be absolutely correct. So I'll go ahead and do that. There we go. All right. So now we need to calculate the expected frequencies. So remember the math here. So for church gate, we have equals, parentheses, it is the column total times the row total. So over here, 31. So 15 and 31, close, divided by the overall value of 60. Now we want to make this so we can drag it. So what do we need to lock in? We want the columns to be able to change as we go across. So what I will do is obviously lock in the total because we want that to be there. I'm going to lock in the column total there in N and hit enter. And now I can just drag across and we'll see that everything works out. So let's do the same thing for the greater than the median. So equals, open parentheses, again, column total times the row of greater than, which is 29 down here, close it, divided by the overall. And again, I will lock in the last two there. Now I can drag across. And now we have our expected frequencies. So we double check our math, 15, 15, 15, 15. No, we're good there. 60 is our overall total. Again, we come up with 31 and 29 for our totals. So the total column should match. That's a way to check yourself. All right, so we know we've done everything correctly. Now we find our p-value using the chi-square test built into Excel. So equals chi-square, and we'll see chi-square test. Our actual range is going to be our data up here at the top. Don't include the total rows, just the store data. Then our observed will be the cells down here at the bottom. Close that. And our p-value is 0.00002. I think I got all the zeros in there. Anyway, it's much, much less than 0.05. So what will we do? Well, we would reject our null hypothesis. Our null hypothesis states that the medians are the same. Well, of course, in this case, because we reject that null hypothesis, or we would say there's evidence to conclude that the medians are not the same. So what is our chi-square critical value? So to find that, we use the chi-square right tail, so equals chi-square right tail. Our probability is 0.05. Our degrees of freedom are the number of columns minus 1, so that's 3, times number of rows, which is 2 minus 1. So 3 times 1 is 3. So 3. So 7.814 is our chi-square critical value. Well, what is our chi-square we observed? So again, we do the same thing. Chi-square right tail. But in this case, our probability is actually what we found in our p-value. 3 degrees of freedom. So we have a chi-square observed of 23.69. That is way, way higher than our chi-square critical of 7.81. Again, so based on that, we would reject the null hypothesis. So using Mood's median test, we can conclude that the 4 medians for the stores are not the same. Let's go back into PowerPoint and finish up this video. All right, so we are back from Excel, and here are our results. So our test statistic was chi-square with an alpha of 0.05 and degrees of freedom of 3. But remember, we had 4 columns, so 4 minus 1 is 3. 2 rows, 2 minus 1 is 1, so 3 times 1 is 3. We rejected our null hypothesis. Our p-value was much, much less than 0.001 or even 0.0001. It was a very, very small p-value. So we reject the null hypothesis and move on to the alternative and say that at least one sample comes from a different population. And if we look at this visually, we're going to say that it's probably the Horniman Circle store. So here is a visual representation of the chi-square curve using our data. So we look at this curve over here on the left, we have two things to keep in mind. The area there in the pink is our alpha level of 0.05. So the area of the curve underneath the curve represented there in the pink is 5% or 0.05 of the area under this curve. The blue section there is our critical value. So remember, the critical value is just the location of where the area of 0.05 starts over here to the right. Now, what is our chi-square value? Well, it's 23.69. Look where it is relative to this curve. It is way over to the right. So of course, because it is in that rejection region over to the right, we reject the null hypothesis. But I want you to see visually what it looks like actually in the chi-square distribution. Okay, so that wraps up this video on Mood's median test. Again, it's actually very straightforward. It's sort of an expanded sign test where we then count the observations in terms of above or below the overall median and then compare that using the chi-square test of what we observed versus what we expected to observe. So I hope you found this video helpful. I hope you found the Excel work helpful as well, where you can go and actually calculate it. And of course, thank you very much for spending your valuable time with me. I wish you all the best of luck in your work and studies, and I look forward to seeing you again next time. Take care. Bye-bye.